Hello dear students, today we are going to discuss the second part of the chapter force and pressure. So first let us see what is the definition of pressure. So pressure we can define as the force per unit area. The force per unit area is known as pressure. So we already defined that what do you mean by a force. Force is defined as the push or pull on an object. So here we are considering the force that are acting perpendicular to the surface. So take the example of this particular writing marker. So just to consider it as a nail and nail. So this is the pointed tip and this is the head of the iron nail or the marker. So here you can see the area is more here, and here the tip the area is less. Okay. So you consider, suppose if I am pressing this particular, you can see here the whiteboard. So if I am placing this particular marker exactly just like this, that means it makes an angle, 90-degree with the whiteboard. So we can say that the marker is now perpendicular to the plane of this whiteboard. Clear? So the forces such are acting in such a way. Suppose if I open my palm and if I place this particular marker exactly just like this. So now the marker is perpendicular to my palm. Okay. So when I press this particular sharp pointed end on my palm, what happens? So I will experience more pressure. So that because the area is less. So if the area is less, then the pressure will be more. So that's why while you hammer the nail, if you hammer over here, the nail will go into the wood so easily. So here what happens, the iron nails, it has got pointed ends. Where the pointed ends, the area is less. Then the same force that getting applied over here, that will exert more pressure over my hand or over the wooden box or wooden surface. So as a result, the iron nail will pierce into the wooden board. And similarly, what you can see, suppose if we try just the reverse case, just like this, if you keep the head of the nail onto the wooden board and if you start striking with a hammer or its tip. So here what happens, will you able to pierce the nail into the wooden board? You will not be able to pierce the nail into the wooden board. What is the reason? The reason is that here the area is more. So that's what we need to specify. Here you can see the area. This is known as the surface area. The surface area of this particular head, this is more. So with the same force, you may not be able to pierce the nail into the wooden board. So more is the area, then pressure applied onto the surface, that will be less. So this condition we need to remember. And again we discussed about what is force. SI unit of force, that is Newton, and the area, SI unit of area is, area means what? Length into breadth. So meter square. The SI unit of area is meter square. So the SI unit of pressure is Newton per meter square, that is known as Pascal. So it is the name of one famous scientist, Blaise Pascal. He proposed a lot of theorems related to pressure. So in order to respect his contributions, we gave the SI unit of pressure as Pascal. And see, here I have already explained. See, just you can see here, this is the iron nail which I have drawn here. This is the head of the iron nail. You can see the surface area. The surface area of the iron nail is large. So look at the pointed tip. The pointed tip, it has got less area. So we can see, if you hammer over here, suppose, see, now it is perpendicular. So as you hammer over here, what will happen? The pointed end can, as the area is less, so as the area comes in the denominator, suppose if 10 by 2, what is that? 5. Here the area, 5 Pascal pressure. So if you keep this reverse, what will happen? If you keep the head over and you apply the same force. The area, the area of the head you take it as 5. So what will happen? The pressure will now become 2 Pascal. So as the area increases, the pressure will decrease, and as the area decreases, the pressure will increase. So this you keep in your mind. Take this example, and the same thing you can also experience if you try to cut vegetables with a knife. So knife has got 2 edges. It has got one sharp edges and a blunt edge. So if you try to cut with a blunt edge, will you be able to cut vegetables so easily? No. The reason is the same. So in some cases, we need to sharpen the object, see, and at some cases we need to reduce the pressure. Suppose you might have seen head load workers. So while carrying load over their head, what they will do? They will keep some amount of large roll of cotton or cloth over their head, and above that they will keep the load. So what is maybe the reason? While keeping the cloth over a large surface area, so what the surface area will become increased, and as a result the pressure of the weight or the weight of the luggage on the head of the porter will get reduced. And similarly, now let us look at the next points. What about so far we discussed about solids. So what about liquids and gases? Will they exert same amount of pressure? Suppose if you happen to inflate a balloon, if you leave it its mouth untied, what will happen? The air will go out. Also you studied about pressure difference in class 7. So what is pressure difference at one place due to the uneven heating of earth surface by sun? What happens? The pressure differences arises. So this pressure differences leads to the movement of air, that is known as wind. So this air pressure differences that will create cyclones and tornadoes, and it will create wind. And similarly, so this pressure difference, it can also be experienced by exerted by gases. Suppose if you inflate a balloon and if you just make a small hole at its end point with a small spin, what will happen? The balloon will blast. So you can see the air which is contained in a balloon, so that is exerting pressure all the sides. That means almost all the sides of that particular container, because we know that we cannot fill air into an empty container. So if we want to fill more and more air into a particular container, we need to, after filling the air, we need to keep the mouth of the container closed. So otherwise what will happen? The air will escape out. So air has a tendency to move here and there randomly. So gases also exert pressure in all directions. So that's why they are free to move. Air is free to move, not just like liquids. Air is free to move here and there. So air can exert pressure in all directions. But what about liquids? Now let us come and look at liquids. So when you look at liquids, what happens here? Suppose take an example. This particular cylinder. At the bottom I have kept one balloon. This is one balloon I have attached. So what will happen? As the height of the water column, see the height of the water column, here it is somewhat less. The height of the water column, I have filled water here, water over here, and the height of this water column is somewhat less. So what happened? The balloon, the water will exert a force in the downward direction. The weight of the water in this particular cylinder, that will exert a force in the downward direction. You can see that. So a force will be acting in the downward direction. As a result, the balloon will start swelling. So here you can see the balloon, it has not that much swollen up. Suppose I have taken another cylinder, see, for example, another cylinder, a bigger cylinder, and the height of the water, you see the height difference. The height of the water which I have taken in this particular cylinder is much more compared to this one. So what will happen? So as the height of the water column increases, it will exert more pressure. It will exert more pressure at the bottom. So as a result, the balloon has fallen little more. So we can conclude that liquids exert pressure at the bottom of the vessel. Clear? So from this activity we can understand that liquids exert pressure at the bottom of the vessel. So what about the sides? Suppose you take a simple plastic Pepsi bottle. Many Pepsi bottle will be at your home. I know that you are fond of drinking lot of Pepsi, I think, is it? So what happens? So you take an empty Pepsi bottle, fill it with water. You can perform this particular activity at home. See, fill it with water and mark a particular point, say at 10 centimeter height. At 10 centimeter height, you make 3 holes. Measure from the bottom at almost 10 centimeter and then mark 3 holes at this particular. These 3 holes should be of same height. Then fill the Pepsi can this particular bottle with water and observe that. You will see that what happened? The water will start coming out of this hole and it will fall over the ground. From this hole also it will start falling, and from here also it will start falling on the ground. So if you measure the distance between from the bottom of the vessel to this particular point, this distance will remain same, and from here also and from here also. The water, that means what? At equal heights. Here, this is a common cylinder. This is a cylinder of which 3 holes are made at same height, 10 centimeter height. The height of the water above this particular 10 centimeter hole that remains same. So water at equal height, suppose at equal height, at this particular height, it will experience same pressure. As a result, water will spread out by equal distance from the bottom of the bottle. And similarly, you can see from this activity, I have drawn one more. Suppose you fix one more one small tube over this particular hole and fix one more balloon over here. See what will happen? As you fill water in the cylinder, the water will start flowing into the balloon. So slowly you will notice that the height of the water column will slowly start decreasing. If you take more amount of water, the balloon will get filled more. So that means what? Liquids exert pressure on the walls of the container as well as at the bottom of the container. And one more thing, at equal height, the pressure will remain the same. I hope it is clear. Just you rewind this video and watch it again, this particular part. So you will understand more. Okay, if you have got any doubt, you can ask me later to WhatsApp. Okay. So now let us look at the last point of this particular chapter, that is atmospheric pressure. So similarly, we had already seen that air exerts pressure and air has got weight. See, if you consider a 15 into 15 centimeters, that means of the size of your head, if you consider, and if you are standing outside on open air, so the air above your head, you can see, consider this particular cylinder, this is the unit area, say the atmosphere. May have heard about the word atmosphere. What do you mean by atmosphere? Atmosphere is the envelope of air, or a layer of air that surrounds the earth in all directions. You can see. So this air also has got weight. So as you stand outside, what will happen? The height of the atmosphere the air cover that will exert a force on your head. So which is actually perpendicular to your head. As you are standing on the ground, what will happen? The air which is present just above your head will press you down. So it is calculated that this particular pressure, so which is equal to the mass of 225 kilograms. Suppose if you are standing outside and holding a box of mass 225 kilogram or weight 225 Newton on your head. So that much is the pressure of atmosphere over your head. That much is the pressure. That much is the force that is getting acted on your head by the atmosphere. So the pressure that is exerted by the atmospheric air, that is known as atmospheric pressure. So it is actually due to the weight of the air. It is actually due to the weight of the air that is acting perpendicular. That is acting perpendicular. We already seen what is perpendicular by making an angle 90 degree to the plane. Weight of the air column acting over a unit area, that is known as atmospheric pressure. So we already defined that what is pressure. Pressure is force upon area. So weight is actually a kind of force only. So similarly, the weight of the air column that is acting over a unit area, so that is known as atmospheric pressure. Normally atmospheric pressure at sea level, that is considered as 1 atmospheric pressure, which is equal to 76 mm of mercury. So this is all about this particular chapter. I hope you read and study well this particular chapter and go through the textbook. If you have got any doubt, you can ask me, or if you need any more clarifications related to this particular topic, you can also contact me through my WhatsApp number. And just these points, these are very important points I have written in a nutshell. So you just take a screenshot of this particular section and keep it, write these points to your copy. So this will be very helpful while you read the textbook, so you can understand it well. Okay, I hope you understood well. Okay, thank you. Stay well and stay safe. Keep yourself safe from this pandemic situation. Okay, thank you.